Okay, first we're going to start looking at the difference between altitude and elevation. Elevation is how far away you are from sea level. That should have been blue, I guess. So let's say that we live on land, and then in that land we have a mountain. So we have two things we want to talk about. So we have the land, and then we have the mountain. So if my house is here, my elevation is how far this is up from the sea. If my house is up here, my elevation is the mountain plus how far over the sea I am. So elevation is how far away from the sea level are you. Altitude, on the other hand, is the distance from a given point. So here it would be the base of the mountain. So if I start a hike here and change my altitude by hiking up the mountain, that's changing altitude. I still have an elevation. My elevation is going to be the distance from sea level. Okay, in environmental lapse rate problems, you need to look at several things. Okay, we'll start with this one. Get rid of this. Okay, so let's start talking about the equation. The equation is the change in altitude times the environmental lapse rate equals the change in temperature. So let's talk about each of these pieces separately. Let's start with the change in temperature. So the change in temperature would be like this morning, it was 24 degrees. And then when we leave school today, it's going to be 44 degrees. So then the change in temperature would be 20 degrees. Now the same thing happens when you go up a mountain, except for the temperature decreases. So in our example, if we started here at the bottom and it was 44 degrees and we hiked up the mountain and then we took the degrees, it could be 24 degrees. So as you go up, temperature goes down. So that's the change in temperature. Delta means change of. Change in altitude. Remember, this isn't change of elevation. So if I'm on my land and I have my house and I have my mountain and I decide to go on a hike, it can give me the elevation here. It can say that it's 2,000 meters, and it can give me my elevation here, which could be that I'm 100 meters from sea level. So that means my house is 100 meters above sea level. So my altitude of my hike is not 2,000 meters. It's 2,000 meters minus that 100. So then we have 2,000 minus 100 gives us where we started. So we started at 1,900. That can't be right. We ended at 1,900 and we started at 100. So here in our example again, let me draw it again. My house is 100 meters above sea level. That's my elevation. I'm going to hike to 2,000 meters elevation, but my change in altitude is going to be from 100 meters to 2,000 meters. So my change in altitude equals 2,000 minus 100. So my change in altitude equals 1,900 meters. Now, for our equation, in our change of altitude times the environmental lapse rate equals the change in temperature, we need to pay attention to our units. To do this, we need change in altitude in kilometers, and we need the change in temperature in Celsius. We probably won't do any changing of Celsius to Fahrenheit. Who knows, we might. So in this problem, for every 1,000 meters of change in altitude, the temperature decreases 6.5 degrees down. Let's say that I'm hiking, and let's say I'm hiking from the beach. So let's say I hike up 1,000 meters. Well, for our equation, we have to change meters to kilometers. So we're going to move the decimal over 3 places, so we have 1 kilometer. So then our equation, the change in altitude is 1 kilometer, times the environmental lapse rate that was given, which is that's going to change 6.5 degrees Celsius for every kilometer that we hike up the mountain, equals the change in temperature. So let's say when I started my hike, it was 16.5 degrees. So I'll do my equation. I get rid of kilometers. So then I get 6.5 degrees Celsius equals the change in temperature. Here's the point, the change in temperature. Started at 16.5, the temperature changed by 6.5, and that's going to give me 10 degrees is going to be my temperature here. Now, how do you know whether it's going to be minus or plus? Well, if we're going down the mountain, temperature is going to increase. If we're going up the mountain, temperature is going to decrease. Okay, we'll keep on plugging it along here. Let's see. Okay, so let's do this problem again together. Okay, so air starts at sea level with a temperature of 26 degrees. So I'm going to draw myself a picture. And I'm going to put 26 degrees. I don't have to worry about altitude and elevation because it tells me that I'm at sea level. Okay? So that says, what's the temperature if I go up to 1,000 degrees? 1,000 meters. Now in this problem, I think it tells you to use the arid environmental lapse rate. So here we go. First step, write your equation. So I have the change in altitude times the environmental lapse rate equals the change in temperature. So my change in altitude, I'm going from 0 to 1,000. I know that I need to know kilometers, so change this to 1 kilometer. So my change in altitude is I started at 0 and I went to 1 kilometer. So I changed my altitude by 1 kilometer. Here we're going to apply that math you've been learning all these years. Times the environmental lapse rate. Well, if we use the dry lapse rate, then we have for every 10 degrees Celsius, that means I've hiked up 1 kilometer, equals the change in temperature. Step 2. Step 3 is plug and chug and solve. So we get rid of kilometers, and we end up with 10 degrees Celsius equals the change in temperature. But we're not done, because remember this is the change in temperature. So we started at 26, I don't know what this is. We started at 26, we lost 10 degrees, and that gives us 16 degrees Celsius. So I hope that helps.